All right, so our next topic is functions. This is an important thing for us when we are thinking about trig, because all of what we're going to be learning in trig is based on trigonometric functions. Sine and cosine are functions. So let's chat about sort of what we typically see with functions. So first, I'm just going to use h, and we'll just do like 3x squared minus 1. So a function is just a shorthand way to say we have a rule and it has a name. So this is a rule, the rule, named h, takes x as an input. So that's what this thing is. So the h is the name, the x is what our input is, and then after the equal sign is exactly what it does with that x. And squares it. I'm just going to follow the order of operations. First thing we deal with is that exponent. Squares x, then multiplies by 3. And then subtracts 1. So you can see how much cleaner it is to do this function notation rather than write out this giant sentence. So the way we use this function notation is it's simpler than having just the expression and saying evaluate this at. Instead of doing all that, I can save myself words and time by just saying what is h of negative 1. This tells me that my new input is negative 1. So everywhere in my original function, everywhere in my original function where x was, right, my original input, I'm just going to go ahead and replace that with a negative 1. So I'm going to put all the pieces back. We needed to multiply by 3, we needed to square, we needed to subtract 1, and I'm just going to go ahead and replace that x input with a negative 1. Negative 1. That's it. That's how functions work. That's the whole point. There's a little bit more to it in terms of domain and range, and we'll review those when we get to our trigonometric functions and we start talking about the graphs. But for now, the one piece we need to know is what evaluating a function looks like, and this is it. It's plugging these things in and then following the order of operations. So squaring first, we have a positive 1, 3 times a positive 1 minus 1. Here we're at 2. So if you want to try this on your own, try finding h of 2, seeing what you get. You should have gotten 11, because again, all we're going to do is take that 2 and we're going to plug it in where the x was. So we'll end up with 4 times 3, which is 12, minus 1, which is 11. Sometimes students will get caught up if I have multiple x's in a function. So let's use a new name. Let's say g of t. If I have something this is like t plus 1 over t minus 2, students will only plug in t once, when really in this case we need to be plugging in t 2 different times. In fact, we could make ourselves a general format for anything that we ask for. We're going to take that number and add 1, take that number and subtract 2, and then divide the first expression by the second. So that's our function notation, is whatever the heck we get. So if we're asked to find g of 3, then we're going to go ahead and just plug 3 in for both of those. So we get 4 over 1. So hopefully that clears up the function notation. I think that'll get you most of the stuff in Delta Math. Yep, there's just some more challenging plugins. Going backwards is one of the things Delta Math has you do, so I'll just go ahead and give you one of those so that you're not caught off guard when that happens. If you have something like h of x is equal to 3x plus 7, and then we're asked to say solve for x when, let's do h of x is equal to, fine, 0 works. So this is working in the opposite direction. We don't have the input, it's telling us to find that, but we do know what the output is. Oops, that's not the color I wanted. We know that h of x is 0. So we can just replace that with my 0, and then we can work through solving this simple linear equation. So this is mostly just about paying close attention to what you've been given and not just always plugging in. I think that's usually what gets students on that type of question, is just sort of plugging and chugging without thinking, turning their brains off. The other thing that you might see on Delta Math is evaluating from a function. So if we have a graph, so let's say, this is real sketchy, but let's just pretend that looks like it's 3, and we'll call that 5. If this happens to be the graph of some function, we can call it whatever we want. Let's go with f. We haven't used f yet. And I ask you what f of 3 is. We have been given the input. And what is the input always when we're talking about graphs? Our input is an x. So this is saying x is equal to 3. Our output, the whole point of the function, is to give us a y. So this whole thing, all of it together, is our y. But it looks like we don't have that. We want y is equal to question mark. So essentially what this notation is saying is there is some point, 3 comma what, is on my graph. So all you're going to do for a question like this is say, oh, I want x of 3. Here's x of 3. Where's my graph? Oh, my graph is over here at 5. 5 is the number that would fill in this ordered pair to get me there. Now again, I have a ton of other resources for this. This is just a quick little overview of everything you're going to need to get through that Delta Math review homework.